Hello everybody. We're here to look at solve by factoring, and I'm on the wrong screen to start. Solve quadratic equations by factoring. So the first thing that you usually ask yourself is, if you've got two things multiplied together and it equals 0, what do you know about them? Well, you know one of them must be 0. It's possible that both of them could be 0, but at least one of them has to be 0. There's no doubt about it. There's no way you can multiply two things together and have the answer 0 without one of them being 0. So knowing that, let's look at this example. I've got two things, two parentheses. They are multiplied together and the answer is 0. If that's the case, I can separate these as separate equations. 2x minus 5, I could set this equal to 0, and 3x plus 1 equals 0. Now, why am I doing that? Well, the reason I am separating them and setting them equal to 0 is to find out what value of x causes the equation to be 0. If there's two things multiplied together like this, it could be as many as two different values of x that make it 0. So let's solve. Add 5 to both sides. Then I'm going to divide by 2. So 5 halves, or 2 1/2, is one answer. And then I'm going to divide by 3 after I subtracted 1. Now we connect these with or because it could be this or it could be that. And this is my final answer. X equals 5 halves or x equals negative 1/3. Now, we didn't actually do any factoring in this situation, but we will be coming right up. These were already factored for us, so we didn't have to do it this time. So here's our next examples. Now this is basic factoring. If you recall basic factoring, the first thing I'm going to do here is everything's already on one side, set equal to 0, so I'm going to factor it. Remember, we said to ourselves, what multiplies to give us this adds to give us this. Because there's no coefficient for the x squared term other than positive 1. I'm going to put my variables in. I'll put my signs in. Now remember your sign chart. A positive, then a negative means you're going to be using a plus and a minus. It doesn't matter which one goes first. And I need a pair of numbers that multiply to 22. Now remember, these pairs, 22, 1 and 22, 2 and 11, and because my signs are different, I'm looking for the pair that differs by 9. And the answer here would be 2 and 11 that differ by 9. I want to put the 11 with the positive and 2 with the negative. I get rid of that out of my way. I'm now going to set each of these parentheses equal to 0 and solve. Subtract 11 from both sides. X is negative 11. Add 2 to both sides. X equals 2. Now the other way you could write this answer, you could say x equals negative 11, comma 2. That's an example of the same thing. You could say negative 11 or 2 instead of having to write x equals or x equals. Same thing. Okay. Over here, let's see. We're going to need to factor this. X plus multiplies to 9, adds to 6, 3 and 3. Now I'm going to set each of these equal to 0 and solve. Oops. All right, subtract 3, x equals -3. Am I going to get a different answer here? The answer is no, I'm going to get the same answer. Do I need to do it out? I do not. Now, be careful. If you have a positive here and a negative here, you will get different answers. So don't just look at the number and assume you're going to get the same answer. And if you're not sure, do it out. Prove to yourself that it comes out the same. Your final answer here is x equals -3. There is no other option because it works in both of these parentheses. Now, just as a reminder, if we went back a little bit, oh, not to there, here, if I plug this expression back into both x's, this expression is going to cause this parenthesis to become 0. Does it really matter what the value of that parenthesis is? No, because if this is 0, 0 times whatever that is still going to be 0. And you can check by plugging this in, and this one's going to be 0, it doesn't matter what this one is. And that's why we find those values and can plug them back in to check. All right, so here are the basic rules here. And this works for all of our solve by factoring. Step 1, solve by factoring. Number 1, get everything on one side so that it's equal to 0. You're going to want the biggest exponent term to have, to have a positive coefficient. Let me get rid of b. I was typing it differently at first and wasn't paying attention. Oop. Paying attention. Oop. Well, there we go. Much better. All right. Got to have it spoken and written correctly. All right. You want the biggest exponent term to have a positive coefficient. Next, factor completely. Look for a GCF, factor it out if you can. Then factor 2 parentheses, all right? Finally, we're going to do that separate, set equal to 0, and then solve it. I refer to that as triple S, just to make it easy to remember. Let's see an example. So, if I move everything to one side, I want the biggest exponent term to be positive. Where is it right now? Right now, my biggest exponent term, x to the second, is here. Is it currently positive? The answer is yes. Now you will eventually run into problems where this is on both sides. Then you're going to have to figure out which side is going to be the best side for it to be on so that you have a positive coefficient. In this case, I'm going to move all this to this side because it's currently positive. I do not want to make it negative. All right, so I'm going to add the opposite of these to both sides, plus 6x. And minus 72. Now these cancel out to 0, and I want to put them in descending order. I've got my x squared term first. None of these are like terms, so I'm just going to write it out. Plus 6x minus 72. Here's where I'm going to factor to 2 parentheses. I've got my x and x, I've got a plus and a minus, and I need to multiply to 72, differ by 6. Let's see, 72, 1 and 72, 2 and 36, 3, and 24, 4, is it 18? I think so. 18, yes. 6 and 12. Hey, there's the differ by 6 and 7. 8 and 9. All right, 6 and 12 are the ones we want. I want my 12 to be positive and 6 negative to get a positive 6. Now, I have factored completely because there was no GCF. I got everything on one side first. Separate, set equal to 0, and solve them. To solve this, I'm going to subtract 12 from both sides. X equals negative 12. Add 6 to both sides. X equals positive 6. And there is my answer to this problem, solved by factoring. X equals negative 12 or X equals positive 6. And there you have it. All right, next example. All right, this is from the Algebra 2 book that we have. And I need to take mine out so I can look at it. All right, page 238. All right, on page 238, it gives me an example, and it says 53. All right. A cafe has an outdoor patio. The patio is a rectangle. The cafe owner wants to add 468 square feet to the area of the patio by expanding the existing patio as shown. Okay. And here's what they show. This is the existing patio, and they want to expand it by extending this direction and this direction. And so the original patio is 20 feet by 30 feet. 20 feet by 30 feet. And they want to expand it equally in both directions. So the distance from here to here is x. Same here to here. Okay. And they say that they're expanding it by 464 square feet. They're adding 464 square feet. So, wow, that doesn't look perfectly same size for both of these. That should be a little bit. Let's see if I can get it to do it. No, I guess I can't. Oh well. So, add 464, I think it was. 464 square feet. That's what they want to add. All right, so first, I want to figure out what x is. Okay. Well, I know that the original shape is 20 by 30, which would equal 3 times 2 is 600 feet squared. All right, that's not very good writing there. Let me fix that. Feet squared. All right. So that's the original amount, and we're adding 464 feet. So if I say 464 plus 600, whoops, 600, that's going to be 1,064 feet, square feet. All right. So how does that help us? Well, that would be the area of this red rectangle, right? That whole thing. The old plus the new together. How can I find the area from here, this, the area of that rectangle? Well, couldn't I say that this much plus this, that's the base. So x plus 20, and then this distance is 30, and then x more. So x plus 30, and that's going to equal 1,064 feet squared. Awesome! We've gotten somewhere. Well, there's a little more work to do than that. I actually need to get this on the other side, but I really need to distribute this out so that I can get all of it as a polynomial, not as binomials multiplied together plus something or minus something. So I'm going to distribute this. And then I'm going to bring this over. This needs alignment. All right. And I'm going to combine like terms while I do this. X squared plus 50x minus 464 equals 0. Okay. Wow. That looks pretty complicated. I have to solve that now, which means I'm going to factor it. No GCF, so I'm going to factor it. All right, let's see. It's going to be helpful for me to probably produce a calculator to help me with this, because I'm going to have to break 464 apart. I can see 4 goes into it. Let's see, 464 divided by 4. 116 times. I know 4 goes into that. 29 times. Okay, so that's 16 and 29. 2, 2, 2, 2, 29. These are the possible values. All right. I have to come up with a setup, x and x, plus and minus. I have to come up with something with these numbers so that when I find the difference of them, it would be 50. Hope I didn't make any mistakes. Here we go. Let's see. 29 times 2 would be 58. And these 3 multiplied together is 8. So 58 times 8, let's double check. 58 times 8, just in case I made a note, is 464. And they do differ by 50. So I need 58 and 8. I'm going to have to align this board. It's just off by a tad. It looks like it got shifted. All right, here we go. Sorry about this. Should have done this before I started today. All right. Now, we know that this is going to separate and solve. X plus 58 equals 0. X minus 8 equals 0. I'm going to subtract 58. I'm going to add 8. Now, let's think about this. We're extending this by a certain number of feet. Do you think I could extend it by negative 58 feet? That makes no sense. So the answer has to be positive 8 feet is how much I'm extending this patio. And that's how we do it. All right, let's take a look at the next example. Oh, it says find the zeros of the function, and they put y in there. But they've got x on the other side. Well, all this really means is put 0 in for y and solve for x. That's what it means. Now, by the way, zeros of a function when it's in this form, that's where, if you used a graphing utility like Desmos or something else, and you found where across the x-axis, that would be the zeros of the function. Now, we're going to find that by factoring, not by using Desmos. Please remember, you need to have a space in front of the x. Our signs are minus, minus. We need a pair of numbers to give us 9 that go here and here. We need a pair of numbers to give us 2 that go here and here. That's 2 lines there. We know the only option for 2 is 2 and 1. Now, for 9, we could use 3 and 3 or 9 and 1. I believe 3 and 3 is the correct option here. We check with smiley face, negative 6x, negative 3x. Sure enough, that adds up to negative 9x is what we want. I'm going to get rid of that. And now we're going to solve. Now it doesn't matter which side you put the 0 on of the equal sign. So 3x minus 2 equals 0. 3x minus 1 equals 0. I'm going to go ahead and solve. Add 2. 3x equals 2. I'll finish it up by dividing by 3. X equals 2/3. Let's do this one. Add 1. Divide by 3. X equals 1/3. And there you have it. Remember, smiley face factoring, we've done that before. Here's our last example. Remember, we're going to get everything on one side, so the biggest exponent term is positive, or has a positive coefficient. In this case, there's our biggest exponent term. Is it positive right now? The answer is no. So we're going to move this to the other side by adding 7x squared to both sides. All right, so I have 7x squared positive plus 4x minus 11 equals 0. I'm going to factor this into 2 parentheses. And a pair of numbers to multiply to 7. Only one option, 7 and 1. X and x. I'm going to have a positive and a negative. I'm actually going to hold off on filling that in so I can figure out where the 11 goes first, and then I'll put my signs in at the end. I know that the 11 can't be here, because that would give me 77 and 1. That's not going to be close. So it's got to be here with 1. That means this is going to have to be a positive 11 and a negative 7. That gives me my positive 4x that I was hoping for. And now I can separate 7x plus 11, x minus 1, set equal to 0, and solve them. Here I'm going to add 1 to solve. And there are my 2 answers. Negative 1/7, positive 1. Please look at this again if you need to. The problems are going to be out of your book today, and they'll be in Google Classroom for you to find the homework for today. And that's it. Have a great day.